Hello, this is Wade Sultan. Today I'm going to be talking about the composition of stars. But first we need to ask the question of, what are stars? Well, stars are not just dots in the night sky. They are nuclear fireballs. To be specific, stars undergo nuclear fusion, which involves the combination of smaller nuclei into larger nuclei. Throughout most of a star's life, hydrogen is fused into helium, which releases a helium atom, two positrons, and a lot of energy, about 3 to 4 times that of fission. This energy is released in the form of photons, which we know as light, and this light is the key to determining the mass of a distant star. Stars emit all wavelengths of light, but they do not emit all wavelengths of light with the same luminosity. Here's a graph of all of the different wavelengths that our sun emits. As you can see, the sun mostly emits visible light, peaking in the yellow-green area, which is 500 to 600 nanometers, as compared to the visible light spectrum, which is 400 to 700 nanometers. To fully understand the different wavelengths that we actually see coming from the sun, however, we must look at two new spectra, the absorption and emission spectra. The absorption spectrum shows the absorption of specific wavelengths of electromagnetic radiation. It looks like a rainbow, but with black lines randomly spotted through it. The location of these black lines is due to the wavelength of light emitted when an electron moves from a high-energy shell to a lower one, but they can move down multiple shells at once. For the sun, these emission lines are called Fraunhofer lines because they are named after Joseph von Fraunhofer, the physicist who discovered absorption lines. In a nutshell, the emission spectrum is the exact opposite of the absorption spectrum. It shows the wavelengths of light released by a certain source. As you may be able to see, when the absorption and emission spectra are combined, you get the continuous spectrum. Every element has its own unique electromagnetic spectrum, and this is how we find the composition of stars in our universe. To determine the composition of a star, you need to look at its absorption or its emission spectrum. By doing this, you will be able to identify each individual element in the spectrum, and then by doing that, you will be able to determine which elements are in the star. The vast majority of our stars today are made of hydrogen and helium. By using the spectrum to determine how much hydrogen and helium is in each star, it can be determined the star's age and how close it is to dying. If there is more hydrogen than helium, then it is younger, while if there is more helium, it is older. Today, we learned that you can use a star's emission spectrum to determine its constituent elements and the percent composition of each of these constituent elements. These have many far-reaching applications for our world today, but those are far beyond the scope of this video. For now, thank you for watching.